continue with our bubble blower that connects to our tool and that connects subsequently to our tool mount for the robot. Again, this is an exercise that generally is useful if you want to connect one piece with another piece. Equally, if you want to look at how to use Grasshopper in combination with the Rhino environment, so you can switch backwards and forwards. So you should be at this stage now. Let's have a look at this shaded. And we have our tool mount, which I gave you. You have hopefully made something along the lines of so a tool and tool mount. And now we want to create something. And in my case, I want to create a bubble blower. And you should follow these instructions and perhaps can make variations or just use it as a general exercise. This also contains how to go from a dimensional to a two-dimensional form. When we use a laser cutter, we do not 3D print, obviously, but we just need a vector line that the laser cutter can use and follow. So, and Rhino makes that rather easy. Right, so these are images, and I do not want to particularly look at them at the moment. So I switch everything off apart from my base plane. And on our let's do tool, let's use layer 3. And let's work here. I do it in what color? Let's make it in gold. Is that good? Yeah, that's all right. So we will see that and we will work in it. So whenever you work in a layer, you need to click it in. When you work with a Mac, it's just this sort of round button. On the PC platform, it's a little tick, right? The lamp and the lock is the same. Okay, so ignore the fact that there on this canvas here is also your tool mount. We work in a different layer, we hide that. So you can work in the same spot on a different layer. Doesn't affect any of the other work you have done. I have given you this B-Rep. So you are familiar with the Grasshopper surface. So I will start with a curve, but not with a straight curve. I want to start with a circle. When you imagine a bubble blower has a hole you blow through and a little upright where this thing is attached to, and then it has these little, I don't know, little extensions to hold the soap and the water. So so I want to sort of mimic that, right? So I'm gonna go and select under the curves tab, under primitives, a circle. The circle node asks us for two entries. At the moment, it asks us for a plane, and it has a plane already. It has the XY plane, so we operate in the XY plane, but it asks us also for a radius. At the moment, we have a radius of 1, and you can see it kind of creates a little circle. Now, there are two ways, as you know now, to insert a number into a node. So it's either via a panel or a slider. I stick to a slider and I give this, let's say 14. Doesn't really matter, but we need to start from somewhere. So I plug this into my radius, zoom out a little bit. So at the moment, I'm literally just working in this sort of top-down view. Okay, right. And I want to make this little extensions, like little hair that sticks out from this circle. So I want to um, divide this curve and create little points. So we go here to the curve tab, and we have under the division tab, we can divide a curve in many ways, but I use this one, divide curve. You can equally just double click on the canvas and type in divide curve. So I plug this the curve into, it asks me for a curve, and automatically it has a set number, which is 10, but obviously this is not what we want. I want, I'm looking at my, let's divide it into 40, let's say. Okay, I want 40 points. And as you know, in everything is parametric and changeable. I also need, so basically I want to extend these lines somewhere, but I want to extend them concentric from here, or basically that they're sort of perpendicular to the circle, if you can sort of imagine that, so that they sort of stick out in an orderly fashion. So I need a point where I can build. So you might have seen the line SDL. A line SDL is a very useful way to make a line. It asks us for a starting point. So the starting point would be an in point or an outer point. So I decided, or I came up with a solution that I kind of copy and paste this, but smaller inside. So I literally just copy and paste this. But let's say I want to have this at, let's put this at 30. You can either just move the slider or just type it in. Okay, so I have an inner and an outer circle, and with equal divisions at the moment. And I want that to remain. So actually I use the same slider to make sure that I don't get confused. And if you want to replace something like a connector, you literally just plug a new one in and you replace the old one. So you delete this one. An inner and an outer. I want to increase this a little bit. So it's nice. So we have these sort of corresponding points, right? Now, how did I do that? So I have a line. The line, the direction, right? I take the direction from the point there. Okay, I start from my, oh, I'm just looking at my diagram, which is unfortunately far too small. Yeah, exactly. So in the line SDL, it asks me for a direction. I take the points from the smaller circle. And I start from the outer circle. And it asks me for a length. If we zoom in, you can already see there's a 1 millimeter extension line, right? Now, I want the extension line to go both ways. So you can do that. And you know that from a panel, when we created points, you can create points, you know, from 3 data points in a panel. So here, let's say I want these to go, whatever, 3 in one direction and -3 in the other. Okay, now let's see whether we get this. No, we need to change it into a wrap and multi-data. So now, do we need to flatten this? Here, exactly, that's something I discovered. I should have printed it much, much bigger. We need, so this is sometimes, nobody, so basically nobody told me how to do this. You just sometimes need to figure stuff out and play around with. Did I graft it? Oh God, my eyesight is terrible. Did I simplify it? Let's see. No. Did I graft it? Yes. Graft does the trick. Yeah. So if you I have no idea what that means, but sometimes you need to kind of play with these. But it's basically the way this data is consumed within this node. So that's something unique. But by basically just playing around, and I knew it would be probably something like that. We have now the point here. I can plug in a point illustrated. Right, so we have a point here. So I have these points. The inner points connect to the outer points. So the start and the direction and the length. Okay, we're almost there. Now, I also want to have right? Now, that caused a little bit of searching yesterday. I need to go into sets. Is it sets? Oh, no, I think it's under display. Right. So sometimes you need to figure out where are things actually, right? So with these points, I wanted to. So if you want to know where the points are, right? And where they start and where they end, you can plug in a panel which is called point list. You find it under vectors, right? So when I draw a circle, the circle doesn't start here. The circle has a start and an end. The circle starts in the center and then it goes from the 0 and then draws basically anti-clockwise. Yeah. So my points arrange anti-clockwise. Now I could select the number 30 point. But basically what I want is I want to have a stick sticking out. And I did various trials. Sometimes you need to try various versions. I tried to kind of use this point on the bottom, but the easier way is actually, I just want to take the half point from here. I ended up using the half point, which was the most logic one, because I can count them. So those points, at the moment, I have the division 40 points. And I can itemize these. So this is something that will become in very handy. Can be for me, it was frustrating in the beginning, but bear with me. And it's called undersets. They're very, very useful things. And this is how we organize data in Grasshopper. And one thing you will start using quite a lot is a list item. It's this one. So what does that mean? Okay. When we list an item, we basically just itemize a list. At the moment, it just shows me the first point, right? Or the points are always starting. If I could take a slider and you can play around with this, right? Set the point here. You can see at the moment I'm choosing the way I slide the slider. It selects the 32. It highlights the point 32. So this is a good way to select a very specific spot in your curve. This is something we will do a lot when we start wire cutting. So we can select this point. I want to have always the halfway point. So halfway is quite easy. You divide the points, because if I, for example, select the number, let's say if we have whatever 40 points or 48 points, and I would have previously selected the number 3, the 30 point, it will move backwards. I want this to be flexible to the maximum, that I have the stick always sticking out in the same position. So how do we do that? We use a division. So we have a division. So we divide. So we divide the amount of points by 2. Again, a panel with the number 2. If I hover over the R, I get a result 48, which is obviously half of 40 half of 48. So I get 24, right? So and I plug this into my list item. 24 here. I get exactly this point, and I extend this, and you should know by now how to extend this with a beautiful STL. Here we go. It asks me for a starting point. And obviously I want to get it in this direction, which is the X, unit X. And obviously I am moving, this is the X and the Y. So this is X plus, this is X minus. So I need to go into the negative. Forlorn slider, and try to keep your code reasonably organized, that you don't create huge spaghetti junctions. So a slider, minus 70. And whenever you do that, I do this still repeatedly. You need a slider and adjust it 70. If you want to go into the negative, you can turn the wheel here. You go OK, and I go minus 70. That's good. I plug it into my X. So direction X. Why are we not seeing it? Direction. The direction is X. The length is 70. And here we have it. So here, the green line, probably want to have it a bit longer. Okay. Right. So I've got that. Now I want to just gather, I want to separate things. So I want to keep this separate from this. Do I? Yes. Not really. Let's merge everything. It's always useful then to flatten things. That means simplifying the data tree, which you already know. So what do I plug in here? I want my outer ring. So that's my outer, so the bigger ring is this one, right? You can always click onto it. It should highlight green. Okay, I start there. I also want my cross sections from the line SDL. So these little cross sections. Yeah, and I'm gonna stick the stick into it. Okay. And let's just kind of hide everything apart from the result. So we have this one. And now kind of a nice funky node is, so we go straight pipe, we plug in all our curves. If you zoom in, you see a pipe appearing. At the moment we have a radius of 1. Now with laser cutting, because I want to in the end laser cut this, it's the radius, so it's 2 millimeters. That might be okay actually. The nice thing, if you right click over the E, you can decide what ending it should have. And I always like these sort of round endings. Makes it look sort of a bit more elegant, right? And now this is probably the time where you can also start, okay, so what, how big is this, for example? So it's 60 centimeters, it's rather big. So I think I go for 40. That's the radius, I mean, 20. Okay. And obviously I need to, let's make this also a little bit shorter. And I think the line extension, so this is 6 right now. I think I need to shorten these ones as well. Now, come on. Doesn't show it doesn't show the data. Sometimes. Here we go. So I go 1.5 and minus 1.5. So this is basically just to increase the surface. Okay, right. Now, when you're there, I also want, so this stick is now fairly thin, so I could possibly decrease this, but I need to do it separate. The nice thing is basically, this already gives me a thickness from a line. So the endpoints, this is basically where it kind of gets a little bit fiddly, or that's where it comes down to preference. So I just want to quickly check endpoints. So I've got the endpoints. And this endpoint, and I want to extend it again with a line STL. And again, I go in this direction. Is it this one? And I go. No, I go -20, obviously, because I go in that direction. Let's see. Exactly. So now I want to pipe this slightly thicker because my slot is 20 mil. Go piping. I have my line. I want to have the ends round and the radius double slash radius. If it's 20, it's 10. Enter. So I get the radius there. Okay. Now that looks like a pill. Not sure too much about it. Right. Okay. Now we merge these two nodes together. We flatten the data. Here we go. I'll plug this in. And this, I think, is also, I pipe this probably differently. Let's leave this for now. Nope. Let's do this. So I take another pipe. I take this one out from here for now. I pipe this also separately. And the radius, let's do 4. No, I'm not going to use a slider. I try to avoid sliders. The more sliders you use, the slower you're. Okay, this looks good. And I also, we can actually plug this in there. Hold on. Have I missed something? Oh no, we need the line SDL. Okay, I can plug this into there. Basically, I just want to have everything in one place, right? So whenever I click onto this, this is the whole shebang, right? And now I can also rotate this. And I rotate it in a plane. Or should I? Rotating is always a bit fiddly. I have not been very happy with the rotate. We use rotate 3D. We plug in our geometry. And yeah, usually I go via degree. This is an angle, but this does the job already. It has the center is at the X and Y, and the axis is Z, so it rotates around the Z axis. Usually, that's perhaps, yeah, let's do that. I switch it over to degrees, panel 90. Right? So I save this, and we can sort of make this into a group. If you want to change the color, so a little bit aggressive, should we go into the pink? Yeah, it's a pink today. Okay, that's looking good. Right, and now is the time. Hide this. So you could 3D print this now. So if we, again, what we can do, we go geometry. You can bake it straight from here, but in order to, I don't know, this is a geometry node that just takes kind of any geometry. It doesn't. Ah, it's a B-wrap. It wants a B-wrap. Yeah, B-wrap is the most democratic of all three-dimensional containers, right? So you can bake it from the B-wrap, bubble blower. I already have one. Okay, let's do another one. Okay, so it's in level 4. Hasn't done it, has it? Sometimes this takes a while. Or is number 4? Number 4 is not visible. Here we go. So we have something. Okay, I save this. And now we have, because we did bake it onto this number 4 layer, I actually move my grasshopper definition. I leave it here for a quick look, but you should basically just follow along. So this is not terribly complicated. And I just basically built this from scratch by just thinking about it, right? And this is how you eventually will end up. You just start building stuff. And it's a problem solving. It's a little bit like a puzzle. I really like to do this sometimes. A bit like a puzzle. Right, I move this to my second screen. And now I also just switch my Grasshopper code off so that we can concentrate on dimensional thing. And as an outline, which I can laser and Rhino does that fantastically with a command which is called make2d. So it's make2d. So you would start make2d, enter, select object to draw, you draw everything, press enter. Now you get a contextual menu. This is your view, so this is your top view, right? You want a projection onto the C plane, so that's the top plane basically, it's the C plane. And you don't want to have the hidden lines, you just want to have the tangent lines. Usually, don't put into group output because you want to edit afterwards. There are a few lines that will be into edit. Okay, so we do group output this. We apply. The make2d is quite a, it's a CPU hungry operation. If we zoom out, it has placed it in the same position. So if we go, sometimes it's quite good if your object is in the center, let's move it a little bit to the side because it usually projected to the center of your X and Y view. So if we look at this in the perspective, right? So you see, on the one side, we have the three-dimensional object, which we can 3D print, and an outline, which we can send almost to a laser cutter. The only thing now we need to do, we go back to our top mode. Let's move this here. So a laser cutter cuts every line. So everyone who has done my 3D technology class knows that. So if you laser cut this, all your round edges will be cut off, right? We don't want to do that. And the quickest way is to use trim. So you use trim, you click on that, and then I would always select the whole lot, and then I press enter. Rhino is always asking you to do next things, right? So I press enter, and now I zoom in, and I just thing, which is, part of the work. So I need to edit that out later on. But you can done. Uh, cell select by length or dimension. Select point, select similar. Select, select similar. Select same. There is a selection, a way to select. Curve. And then we go to select. Now do it. Sometimes you can select similar items. Perhaps you can find a tutorial. Let me know. So I just go again, select cutting object, enter, and I just click on all the right. So I'll continue this, but I will edit it. You can also just highlight and delete. Consider is if you come from three-dimensional object and it kind of basically just kind of creates everything nice, neat, and tight. This is why it's important to design everything in 3D because you can extract the 2D data in a much more precise, easy way. The a builder's tool. They run this like okay. Not this one, this one. And here on the bottom we have these ones. Actually, I wanna have it. I just take this one off. This looks nice. Okay, and I group this. I press group, type in group, press enter. So whenever you click on it, you don't select one thing. So now I actually just throw this away because I've got the data in my Grasshopper file and I can always, revisit that. So now let's have a look at what we actually have. Now we have this one with from the top view. And so basically this you can now export. If you export this as a DXF, you go export and it asks you select the object to export, and you always export objects in the top view, right? It can be confusing for other programs when you actually import something that is in the wrong position. So always project it onto the ground plane, yeah, to the top view. So I select this one now, which we have edited. I press enter, and here You always go when it goes to the laser cutter, DXF, bubble blower. Okay, let's just kind of save this file. And I bubble blow, bubble laser cut. Let's cut this next week. And I export it as a DXF, and then you get the options. You need to click R12, right? Always R12. It's a bit like a BREP. It's the most democratic form of a DXF. So any old laser cutter can read it. And you export it, and export it. It comes again, export, and then you have your DXF as a file in that folder, right? So I want to go back to my standard view, to my 4 viewports, and so I just want to just quickly see how this looks. I go 90 and 90. Sometimes you have to fiddle around with this a little bit. So we have it now in the top view, and we need to also 90 like this, right? And then we can just drag it into position. And up. This is just to kind of see how it will look with the laser cut piece and how it fits together, right? And I want this in the wireframe mode. Okay, so this is way too big. I need to adjust this. We can also move this. It should be actually, if we move this is in the X, Y, Z, or here 0 and here 0 and 0. And this is 20. Okay, so it should be in the right position. And we have now 3 dimensional files, 2 dimensional files. Okay, so I will change this for next week. That's easy enough to do. This is 3 dimensional, yeah, 3mm acrylic, and just stick it. Okay, that is really all. So from to a environment, then from Grasshopper into Rhino, and so this is the central workflow. I hope you, if you're interested in making things and you sometimes you preparing files, this is a very good way to process designs, and building or a robotic tool to building houses. This program can do everything, and the only limit there is really your imagination and the amount of work you're happy to put into it. But yeah, it gives you a lot of power and with what we have at our for it. Okay, I'll try to get it uploaded as soon as possible. Send the link out. See you next week.